Hello students, in this video we will learn about the refraction of light. What is the definition of refraction of light? When light goes from one transparent medium to another transparent medium, then change their path or change their direction. This event is called refraction of light. So we will understand this by the diagram. This is the first transparent medium and this is second transparent medium. Okay. And we will understand this by the ray nature of light. So when light ray falls obliquely on the interface, this is the interface. This interface separates the two transparent medium. This is not surface. This is interface. Okay. So this light ray is called incident ray, and this point where incident ray falls, this point is called point of incidence. Okay. This is O. Draw the normal on the interface at this point of incidence, and we can extend this normal in other medium. The angle is this. This angle is subtended by the incident ray with the normal. This angle is called angle of incidence and it is denoted by small I. Okay. When light ray enters in other medium, then light ray changes their path or bends. Okay. So if this is the rarer medium and this is denser medium. Okay. Denser medium means optically denser and rarer means optically rarer. Okay. Optical density of the rarer medium is less than the optical density of denser medium. This is not mass density. Okay. Now when the light ray comes from rarer medium to denser medium, then light ray bends towards the normal. This is normal, then it bends towards the normal, and this light ray is called the refracted light ray. Okay. So refracted light ray and this is the normal. So reflected light ray makes an angle with the normal. This angle is called angle of refraction. Okay. Now why this light ray bends towards the normal? Why it does not bend away from the normal? So light ray will bend away from the normal also. So we will see this in this diagram. This is first medium and this is second medium. Okay. Light ray comes obliquely on the surface or on the interface of two separated mediums, and we draw the normal at the on the surface, and this is point of incidence. This can be extended. Now this is incident ray, this is normal, this is angle of incidence. And when light ray goes from optically denser medium to the optically rarer medium, if this is denser medium and this is rarer medium, in the case that if light ray goes from denser to rarer, then it bends away from the normal. This is normal, so it will bend away from the normal, and this is the refracted light ray in this case. So angle subtended by refracted ray with normal is called angle of refraction. It is denoted by small r. Okay. So here you have to remember here that when light ray goes from rarer to denser, then it bends towards the normal, and when light ray goes from denser to rarer, then it bends away from the normal. Why it is done? So we will understand this later. Okay. So this is the refraction of light. Okay. So here there are two laws of refraction. First law, according to the first law, the incident ray, refracted ray and normal to the interface lie on the same plane. In this case, This is incident ray, this is refracted ray, and this is normal. So incident ray, refracted ray and normal to the interface lie on the same plane. This is the first law of refraction. How these are in same plane? So you can look here. Let this is the surface, this is the interface, like that, and it separates two different mediums. So it at that point here, this is the surface, this is the surface. Incident ray lies on this surface, okay, and refracted ray is also lies on this surface, on the surface of board, and this line is also lies on the surface of board. So these incident ray, refracted ray and normal lie on that surface of the board. So these are in the same surface. Okay, this is the first law of refraction. And second law, according to the second law, sine of angle of incidence to the sine of angle of refraction is equal constant. Is equal constant. This is the angle of incidence. So the ratio of sine of angle of incidence to the sine of angle of refraction is constant. This is the second law of refraction. Okay, and this constant is called the refractive index. This constant is called the refractive index. Okay, we will understand this later. First, this is the second law of refraction. This law is also called the Snell's law. Which law? Snell's law. Okay. This second law of refraction is also called the Snell's law. Okay. Now we will understand now about the refractive index. So in general, what is the refractive index? You know, in the refraction, light bends when it enters in another medium, then light bends. Okay, here the measure of bending of light by the second medium. This medium bends the light ray, this medium is also bends the light ray. Okay, so the ability to bend the light ray by the second medium, this ability is called the refractive index. Okay, or the measure of refraction, how much this refracted ray bends. This ability of the second medium is called the refractive index in general. Okay, now why this light ray bends towards the normal or away from the normal? Due to the velocity of light ray in different medium is different. Okay, in the rarer medium, the velocity or the speed of light ray is smaller, and in the denser medium, optically denser medium, the velocity of light ray decreases. Okay, because the material of second medium is dense with respect to first medium, and here material of the first medium is rarer. That's why this is called the optically rarer and this is called the optically denser. In this case, this is called the optically denser and this is called optically rarer. Okay, so the cause of the refraction of light, that the speed of light in different mediums or in different material mediums is different. That's why light ray bends or refracts. Okay, now so how much light ray refracts, how much light ray bends? the measure of bending of light ray by the second medium is called the refractive index. And it is the formula or the definition of the refractive index of the second medium is denoted by n, or it is denoted also by mu. Okay, so we here representing the refractive index by n. Okay, so the refractive index of second medium n2 with respect to first medium n21, it is equal if the rarer medium is air and this is water or glass. Okay, so here the formula of refractive index will be speed of light in air or vacuum to the speed of light in medium. Okay, so this is the definition of refractive index. Okay, so the refractive index is defined as the ratio of the speed of light in air to the speed of light in medium. So when light ray goes from air or from a vacuum to any medium, then the refractive index of second medium with respect to air is called the absolute refractive index. Okay, this is the first type of refractive index. Okay, then let this in this here in this diagram, let this is the rarer medium and this is denser medium, but this is not air or this is not vacuum. This is like that, this is water. We can take here water, and then this is glass or kerosene, and etc. Okay, here this is the rarer medium but not air, and this is the denser medium. So when light ray goes from one medium to another medium, okay, then here the refractive index n21 will be equal to speed of light in first medium to the speed of light in second medium. Okay, so this refractive index, when light ray goes from air to any medium, then the refractive index is said to be the absolute refractive index. But when light ray goes from first rarer medium other than air, when light ray goes from rarer medium to denser medium, then the refractive index of the second medium is said to be speed of light in first medium to the speed of light in second medium. We know that the speed of light of in air is denoted by c. Okay, and let the speed of light in the of this medium in this medium is v. Then the refractive index n21 will be c upon v. This is the formula of absolute refractive index, where c is the value 3 into 10 to the power 8 meter per second. Okay, so this is the formula of absolute refractive index. And let the velocity or the speed of light in first medium is v1 and speed of light in second medium is v2, then the this refractive index is said to be relative refractive index. Okay, so the relative refractive index, the speed of light in first medium v1. Speed of light in second medium v2. It is equal to n21. Relative refractive index. Okay, these are the types of refractive index. Okay, now we know that here when light ray goes from air to denser, it bends towards the normal, and uh, when light ray goes from denser to rarer, then it uh, uh, bends away from the normal. Why bends towards the normal, or why bends away from the normal? So we will discuss about that. Okay, so you know that the Snell's law, sin I upon sin R, it is equal to constant. This constant is called the refractive index, and we know that the refractive index is denoted by n, refractive index of second medium with respect to first medium. So this is the Snell's law, or formula of Snell's law. Okay, now let the relative refractive index is, the absolute refractive index is n21 equal c upon v, and the relative refractive index is n21 v1 upon v2. Okay, now this is the relative refractive index. Here we know that if the refractive index of first medium, this is the first medium, if the refractive index of first medium n1 and the refractive index of second medium is n2. Okay, so we know that refractive index of second medium n2 will be equal c upon v1. v1 not, here v2, because the velocity or speed of light in second medium is v2, and the refractive index of second medium will be c upon v2 from this equation, and the refractive index of first medium n1 will be c upon v1. Okay, c upon v1. So this is called the refractive index of first medium with respect to air, and this is called the refractive index of second medium with respect to air. These are called. Okay, now on putting the value in this equation, so n21 will be equal, the value of we have to put here value of v1 and value of v2. So from this equation v1 will be c upon n1, and from this equation v2 will be equal c upon n2. So the value of v1 in this equation will be c upon n1, and value of v2 equal c upon n2. Okay, or c upon n1 into n2 upon c. C cancel by c, then n21 will be n2 upon n1. Listen here. So the refractive index of second medium with respect to first medium is equal to the refractive index of second medium to the refractive index of first medium. Okay, so this is another formula of refractive index, but we have the formula of refractive index by Snell's law is this. So here we have to put the value of n21 in this equation from this equation. So here sin I upon sin R will be equal, the value of n21 is n2 upon n1. Okay, n2 upon n1. So this is another formula of the refractive index, or is the formula of Ohm's law. Okay, this equation can be written as sin I into n1 equal n2 into sine r. This formula is called the generalized formula of Ohm's law. This is generalized form of, or generalized formula, or generalized form of Snell's law. Okay, now here we are assuming that the light ray falls on the interface obliquely. If the light ray falls on the surface normally, then what will be there? So we will discuss about this. This is the interface, this is first medium, this is second medium. If light ray falls normally, okay, when we will draw the normal at this point, so normal should be like that. So normal to the interface and incident light ray coincide to each other. Then we will again extend the normal, and then the refracted ray will not bend. Okay, the refracted ray will not change their path or not change their direction. So in this diagram, here normal is this and incident ray is also this. So the angle between them will be I equal 0. And here refracted ray is this and normal is also this. So the angle of refraction R equal 0. So from Snell's law, sin I upon sin R, here this is n to 1. So on putting the value of sin of I in this equation, here sin 0 upon sin value of R is 0, this. So n to 1, because sin 0 is equal 0 and sin 0 is equal 0. So here n to 1 will be equal 0 upon 0. Okay, or n to 1 equal 0. It actually this value is not determined, but in the numerator here 0, that's why we can take here is equal to 0. So here the refractive index, this is the refractive index of second medium with respect to first. Here refraction does not take place. Okay, so refraction is not there. In this case, when light ray falls perpendicular to the interface, then refraction is not there. Okay, in that case. Now here we know that when light ray goes from rarer to denser, then refracted light ray bends towards the normal. Why? So you know that sin I upon sin R equal n to 1, and again in the previous step we derived that n to 1 equal n2 upon n1. Okay, and this is the value, and sin I upon sin R equal n2 upon n1. And another formula, we know that sin I upon sin R equal n2, sin I upon sin R, or n to 1 equal V1 upon V2. Refractive index, relative refractive index of second medium with respect to first medium is equal to V1 upon V2. The speed of light in first medium to the speed of light of second medium. Okay. So, but n21 equal sin I upon sin R. That's why we are writing here sin I upon sin R equal V1 upon V2. Okay. If I and R are very small, then the sin I can be written as I and sin R can be written as R. On putting the value in this equation, so sin I equal I and sin R equal R equal V1 upon V2. This is another formula. Okay, here this is rarer medium and this is denser medium. The speed of light in rarer medium is V1 and the speed of light in denser medium is V2. Because we know that the speed of light in rarer medium is greater than the speed of light in denser medium. So V1 is greater than V2. If V1 is greater than V2, from this equation V1 is greater means I will be greater than R. So I will be greater than R. In this case, because I is greater than R, that's why when light goes from rarer to denser, then it bends towards the normal. Okay. Now, in this case, this is denser medium and this is rarer medium. Okay. You know that the velocity or speed of light in rarer medium is greater than the speed of light in denser medium. So V2 will be greater than V1. If V2 is greater than V1, then from this equation V2 is greater than means R will be greater than I. Therefore R will be greater than I. Okay, because I is less than R or R is greater than I, that's why when light ray goes from denser to rarer, it bends away from the normal. Okay, because I is less than R. This is the conclusion. Now, the refractive index in different medium is different. So we will discuss about that. By the numerical values of refractive index of different medium. The refractive index of air Na is equal 1.0003 like that, and the refractive index of water Nw with respect to air is equal 1.33, and the refractive index of ice with respect to air is 1.31. Okay, and the refractive index of kerosene with respect to air is 1.44. Okay, and the refractive index of crown glass with respect to air is 1.52, and the refractive index of flint glass with respect to air is 1.65, and the refractive index of diamond with respect to air is 2.42. Okay, and the refractive index, these are the refractive index for different medium. Okay, here you can see that the refractive index of diamond with respect to air is greater than the refractive index of other mediums. Okay, these are the numerical values of refractive index for different mediums. Okay, so I hope you would have understood all the things. Thanks.